Hello, good morning. You're welcome to Study Statistics with me, Osman Abdul Baki. Today, we would like to talk about indices. That is the principle, rules, and properties of indices. So, without wasting much time, we would like to go straight to the properties. We have 8 properties, and I think if you would like to know more, then you have to go through the books or some of the books and or to go to online and do more research about it. But these are the main properties that I would like you to know more of. So for the first property is a multiplicative property where when the bases are the same and you are when the bases are the same, you are supposed to add the the exponential or the power. So this taking this is known to be the exponential or the power or the power, and this is the base, right? So when you are multiplying and the bases are the same, that is where you need to add the exponential of the power. So multiplicative or multiplication go with addition of powers. Multiplication goes with the addition of powers. That is what the rules or the properties of indices says. Now let's go to the second property. When the bases are the same and you are dividing, you subtract the powers or you subtract the powers. When the bases are the same and you are dividing, you subtract the powers. So here that is why we have m minus n. That is, you subtract n from n. All right. So now let's go to the property number 3. The property number 3, it just when the base when any value has the power and being multiplied by another power, you just have to multiply the both powers, then you get to your final answer. So imagine we have 2 raised to the power 3, 2 raised to the power 3, power 2. It's just a matter of multiplying 3 times 2. So it's the same as 2 power 6. You multiply 3 times 2 to get the 6. This is almost the same. It is the same as this one. So now let's come to the property number 4. The property number 4, here any value with the power 0 is 1. That's what you need to know. Any value that is raised, even if 100 million raised to the power 0 is 1. So even 10 raised to the power 0 is 1. 1000 raised to the power 0 is 1. 1 million raised to the power 0 is 1. So what you need to know, any number raised to the power 0 is 1. So let's go to the property 5. The property 5 is a raised to the power minus n is the same as 1 over n. So what here you just have to pull the base and the power upwards to get the minus n. 1 over n is the same as a raised to the power minus n. That's the property, the fifth property you need to know. And here, the seed property. The seed property is a raised to the power 1 over n. So this is the nth root. So the n indicates the root we will have. So if we have a raised to the power 1 over 2, that is the square root. So we'll get square root. So square root. But if we have a raised to the power, let's say 1 over 3, we have the cube root. So we have the cube root. So So here is supposed to be A. So we'll have the key root. Actually, it is the root, the nth root. So this is the nth root. Now let's come to the property 7. The property 7, A times B all raised to the power m. Each and every term will get or will be multiplied by the power of the value. So here the same thing. So imagine you have let's say 2x raised to the power, raise the bracket, 2x raised to the power, let's say 3. If you have 2 raised to the power, if you have 2x times raised to the power 3, you will get 2 raised to the power 3 times x raised to the power 3. So each term will have the each term will be multiplied by the power, or each term will be having the power of it, or maybe the power will have each of the term. So now let's come to the property 8. The property 8, when they have the same base and you are equating them, you just have to equate the power of the exponential. If they have the same power, or sorry, if you have the same basis, you just have to equate the power that they have. Imagine maybe you have let's say you have 2x. So imagine you have 2x equal to, let's say, 3 raised to the power 4. Sorry. So let's say, okay, let's make here to be 3. So imagine you have 3 raised to the power x equal to 3 raised to the power 4. Automatically your answer will go into x is equal to 4. Remember, they have the same basis. They have the same basis to be 3. So you just equate the powers. That's all. All right, now let's come to the questions. We have about 5 questions that we'll solve. So now here we'll solve the questions based on the properties that we have. Now the question is 32 times x raised to the power 5, x raised to the power 5, all raised to the power minus 2 of 5. You know, these properties, this question relate to the property. Now let's become property 7. So this question is from property 7. So from property 7, but before then, we want to convert the 32 to a certain figure in which a certain limited figure in which when we find the exponential of it, we can cancel, or we can make off the cancellation of the 5 of the 5. So here we can 2 raised to the power 5 is the same as 32. So that is why we convert the 32 to 2 raised to the power 5. So after this, we just apply our property 7. Our property 7, where each term will have the power, of the function or of the value. So here 2 raised to the power 5, x raised to the power 5, all over minus 2 over 5. So here each term will take the the power or the exponent. So here we have 2 raised to the power 5 times the exponent of minus 2 over 5 times x raised to the power 5 times the exponent. You know, we mentioned that each term will have the power of the function. So here 2 raised to the power 5 raised to the power minus 2 over 5. Here too we apply one of the properties. Here too we apply one of the properties. Here too. So property 3, m times n. Property 3, where we apply property 3. So here too the same thing. So just like having a n times m is the same as a times m n. So here too 5 times minus 2 over 5. 5 times minus 2 over 5. So here the 5 here will cancel this 5 to be minus 2, and 5 here will cancel to be minus 2. So we'll have, and here we'll have 2 raised to the power minus 2 times x raised to the power minus 2. And here too we will apply the same another property of property 5. So here too we'll apply the property 5, where a raised to the power minus m is the same as 1 over a raised to the power n. All right, so here is the same. That is why we bring it down here. The property 5 is here, so 1 over 2 raised to the power 2 times 1 over x2. Then you just multiply them to get your final answer. So this is the final answer, 1 over 4x squared. So that's the final answer. Now let's come to the question 2. Question 2 too, we have the same properties that we must apply. Here too, we would like to turn the 16 into a certain value in which we can make a cancellation. We can get rid of some of the powers. So here 2 raised to the power 4 is the same as 16. So we have 2 raised to the power 4 times x raised to the power 12 all over 3 over 4. And here it's simple for us to apply our properties where we have a n times m, which is equal to, or let me use this property instead, where we have ab times m is the same as am times bm. So 2 raised to the power 4 times 3 over 4. Each of the term will take the each of the term will take or will be multiplied by the power of the function. So that's where we have 2 raised to the power 4 times 3 over 4, x raised to the power 12 times 3 over 4. So here the 4 will cancel the 4. We have 2, it will left with 2 raised to the power 3, and here 4 will go into 12 3. We have 3 times 3, and here will be 3 remaining. So we have 2 raised to the power 3 times x raised to the power 9. So this is the final value. We have 2 raised to the power 3 times x over 9. So maybe you can move on to simplify it to be 8 times x raised to the power 9, because 2 raised to the power 3 is 9. All right, so now let's come to the third question. So here we would like to find a. Here we want to find a. So here we have 32 root 2, which is equal to 2a, 2 raised to the power a. And remember, this is the square root. Remember, we have the root here, that is the nth root, that is the property 6. So applying it here to be just like having 1 over 2, which is equal to the same as square root, the same as 1 over 3, which is equal to the cube root. All right, so here we'll convert the root to be half, and here to remember, we want the bases to be the same. We already have base 2. It's just a simple form of turning the 32. We want to find a way in which we'll convert the 32 to make it base to be 2. So here just a matter of converting 32 to 2 raised to the power 5. Remember, 2 raised to the power 5 is equal to 32, and we want all the terms to have the same basis so that it will be easy for us to make our simplification. So here, remember, when you are multiplying in indices and the bases are the same, you add the you add the exponential. I hope you remember this property where we have a times n. So sorry, a raised to the power n times a raised to the power m. When the bases are the same, you pick one of the bases and you add its exponential. So here it will be n plus n. So the same thing. So here you have the same basis. So it's just a matter of picking one of the bases, then we will add the exponential. That is 5 plus half. 5 plus half, which is equal to 2a. And here to remember, that is 5 plus half is 11 over 2. And remember this, when this is the property 8. When we have the bases are this, when the bases are the same and they are equating, when the bases are equating themselves and they are equal, you just then you just make the exponent, then you just make the exponential to be equal. You equalize the exponential. So that is this property 8. here the a raised to the power m was equal to n. We just equal um the power. So the same thing apply here. You just find the value of the equal. I mean, just equalize the powers instead. So when the bases are the same, you will equate the powers. When the value are the same, you will equate the when the bases are the same, you equate the powers. So here a equal to 11 over 2. Now let's come to the fourth question. The fourth question is just a matter of applying the principles that we have used. It's so simple. So here the same thing, 2x raised to the power 1 over 2 times 2x raised to the power 3 all over 1 and 3 over 2. The same thing, assuming just like having a over b raised to the power n. So a will be a raised to the power n times b raised to the power n. So here the same thing. So here we will have after evaluation you will have 2 raised to the power 1 over 2 because each term will be taken up. Each term will be taking the power. We have 2 raised to the power 1 over 2 times x raised to the power 1 over 2 times 2 raised to the power 3 over 2, and here too x cubed will multiply the power 3 over 2. And remember 3 3 times 3 over 2 is to 9 over 2, so we have 9 over 2. We have 3 over 2, 1 over 2 of that. So this is a term after simplification. And here you want to group the common terms. So we have 2 over 2, 1 over 2 here. We have 2, 1 over 3. So we want to group the common bases that we have, and we have x to be here, x here. So we'll multiply the common terms. We have so this is the common term that we have, x over x and 2 x and x. So here after applying the properties, you multiply, you add the bases. When you are multiplying and they have the common base, you add the bases. So here we have 2 raised to the power 1 over 3, 1 over 2 plus 3 over 2 times here when you are multiplying with common bases, you will add the powers or the exponential, the same thing. So here we have 1 over 2 plus 3 over 2 is 2, and here 1 over 2 plus 9 over 2 is 5. So 2 raised to the power 2 times 2 raised to the power 2 times x raised to the power 5. That's the final answer. 2 raised to the power 2 times x raised to the power 5. So that is the final answer. Now let's come to the final question. The final question says that express 8 raised to the power 2x plus 3 in the form of 2y, stating y in terms of x. So here too, this is the question that they are giving for you to simplify. And remember, we would like to convert the 8 to a possible number in which we will get the exponent. Yeah, and remember we want to express it in the form of this. So we want to convert the number 8 into a certain power in which we will get 8. So we want 2 raised to the power of certain number that will get 8. So 2 raised to the power 3 will give us 8. It's almost the same. So it's the same. So 2 raised to the power 3 times 2x plus 3 will give us the same thing, 8 raised to the power 2x plus 3. But we want to express it in the form of 2y. That is why we want the 8 to be in its form of 2 power 3. 2 power 3 will give us 8. So here we'll just multiply the 3 by the powers of this. So here we'll get 6x plus 9. 3 times 2x is 6x plus 3 times 3 will give us 9, which is equal to our given term, which is 2y. And here, since the bases are the same, we will equate the powers. So here we'll get 6x plus 9, which is equal to y. So yes, that is why hence y is equal to 6x plus 9. So this is the final answer. So this stating y in terms of x. So this is the y expressed in the form of x. So this is the final answer. Thank you very much for having time with me. If you have any questions, you can message me on osmanabdulbaki@gmail.com. I would like you to subscribe more on this so that you get more of the videos in a simplified and a very clear explanation of mathematical questions and solutions. Thank you very much for having time with me. Once again, my name is Osman Abdul Baki. Thank you very much.